By the end of this lesson, students will be able to solve rational equations. Before we begin, what are rational equations? Rational equations are equations that contain at least one fraction with the polynomial as the numerator or denominator. Rational equations can be useful tools for representing real-life situations and for finding answers to real-life problems. For example, in farming, rational expressions and equations can be used to help you answer questions such as how long it will take you to plow a field, or help companies such as Alain Farms decide how to combine workers and machinery to complete a job on a specific time frame. Example 1. Solving rational equations. We have the equation x plus 6 over x minus 8 equals 0. To begin with, I will rewrite this equation. So I've got x plus 6 over x minus 8 equals 0. As you can see, I have left a small gap deliberately so I can use this to show my workings. In order to solve this equation, we will use the LCD approach, whereby we will multiply each term of this equation with the least common denominator, which in our case is x minus 8. So I have multiplied each term with x minus 8. So on this side we will have x with x minus 8 plus x minus 8, and the x minus 8 will cancel out. So we have plus 6 equals 0 multiplied by x is 0, 0 multiplied by minus 8 is also 0. It is important to recall that anything multiplied by 0 is 0. Next, we will use the distributive property to multiply the terms. So x multiplied by x gives me x squared. X multiplied by minus 8 is minus 8x plus 6 equals 0. What we have here is a quadratic equation. Now we have learned we can solve quadratic equations using several different methods. The two most popular methods are solving by factorizing and solving using the quadratic formula. In this case, we will use the quadratic formula. So the quadratic formula is x equals minus b plus minus root b squared minus 4ac over 2a. Now a good tip I would give you is to label each variable. So a equals the coefficient of x squared is going to be 1, b is minus 8x, so we'll have minus 8. It is important to recall that the minus is attached to the 8. Common misconception is students tend to leave that out, and our c is going to be 6. So now that we have our a, b and c, we can use this into our formula. So x equals minus, and our b is minus 8. Instead of writing minus minus 8, we will write this as 8. We've got plus minus root b squared, which is minus 8 squared, minus 4 multiplied by a, which is 1, multiplied by c, which is 6, over 2 multiplied by 1. Now we will continue to simplify this. So we've got x equals 8 plus minus. If we simplify the root, we will have 2 root 10 over 2. We can further simplify that. Okay, so we can further simplify and we will have our answer as 4 plus minus root 10. This is our final solution to this equation. We can work it out by doing 4 plus root 10 on a calculator, and we can also do 4 minus root 10 on a calculator.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson, you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
Example 2. Solve a rational equation with extraneous solutions. An extraneous solution is a solution to an equation that emerges from the process of solving the problem, but it is not a valid solution to the problem. Extraneous solutions can arise naturally in problems involving fractions with variables in the denominator. We will explore this further in the example below. To begin with, we will rewrite this equation. So we've got 4 over x squared minus 6x plus 8 is equal to 3x x minus 2 plus 2x minus 4. In order to solve this equation, we will use the same approach that we used in example 1, where we will multiply the terms by their LCD. So the least common denominator in our case is going to be x minus 2 and x minus 4. This can be achieved by finding the LCD of the terms. So if we factorize x squared minus 6x plus 8, we will have our x minus 2 and our x minus 4. So I'm going to multiply each term with this. Okay, I'll put this in a bracket, and I'm going to have x minus 2 with x minus 4. Next, we will simplify. So this is cancelled out by this. So we have 4 equals, on this side we will have 3x with x minus 4 plus 2x minus 2. Next, we will use the distributive property to simplify. So we've got 4 equals 3x multiplied by x gives me 3x squared. 3x multiplied by minus 4 gives me minus 12x. Plus 2 multiplied by x is 2x. 2 multiplied by minus 2 gives me minus 4. I will simplify by collecting the like terms. So I'm going to group the terms. So I have 4 equals 3x squared minus 10x minus 4. What I will do next is I will subtract 4 from both sides, which will give me 0 equals 3x squared minus 10x minus 8, which is now a quadratic equation. Now we will solve 3x squared minus 10x minus 8, this time using factorizing method. So if I factorize these, I will have 3x plus 2 and then x minus 4 in the second bracket, which is equal to 0. So I will separate each bracket. So 3x plus 2 equals 0 and then x minus 4 equals 0. Minus 2 minus 2, 3x is equal to minus 2 divided by 3 divided by 3, x equals minus 2 over 3. Next we will plus 4 plus 4, x equals 4. Now if we go back to our original equation, because the original equation is not defined when x equals 4, we can eliminate this as an extraneous solution. So the final solution to our equation is x equals minus 2 over 3. Example 3. Solve a rational equation. So now we have a real life question. So the diagram of an electric circuit shows 3 parallel resistors. So the main function of a resistor in a circuit is to control the flow of current to the components. You might recall this from your science lessons. So if R is the equivalent resistance of the 3 resistors, then 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. In this circuit, R1 is twice the resistance of R2 and R3 equals 20 ohms. Suppose the equivalent resistance is equal to 10 ohms. Find R1 and R2. So first, I will highlight my key information. So my equation is part of my key information, and it's telling me R1 is twice the resistance of R2, which is very important, and also R3 equals 20 ohms. And then it's saying, suppose the equivalent resistance is equal to 10 ohms, find R1 and R2. So this is my key information that I have picked out from the paragraph of information that they have provided. Next, I will write out the equation that they have provided me. So 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. It is very important to label each variable. So we know R is going to be 10 ohms. They told us that in the question. We also know R1 is going to be twice the resistance of R2. So R1 is going to be 2R2, and then R3, they have told us, is going to be 20 ohms. So it's very important to label the variables. It will help you later on. Now, in the next step, we are going to put our variables into the equation. So instead of 1 over R, we will have 1 over 10 equals 1 over R1, which is our 2R2, plus 1 over R2 plus 1 over R3, which is, we know R3 is 20 from the information they gave us in the paragraph. So now that we have done our substitution, next we will start solving this. So we're going to subtract 1 over 20 from both sides. So we will have 1 over 20 is equal to 1 over 2R2 plus 1 over R2. Okay, so I'll put a bracket around this. So we can use the same method that we have been using throughout this lesson to solve this equation. So we are going to multiply by the least common denominator. In this case, our LCD is going to be 20R2. So that's our LCD. So I'm going to multiply everything by 20R2. So by 20R2 and by 20R2. So R2 equals 10 plus 20. So what we have is R2 equals 30. So now that we have worked out R2, we can use this information to work out R1. We know that R1 is going to be 2R2. So we are going to double our 30, so we're going to have 60 ohm. So R1 is equal to 2R2 or 60 ohms. We now have both of our solutions. We have calculated both R1 and R2. Having completed the examples, have a go at the task. You can pause the video here, and after you have completed the task, if you press play, the solutions will follow. The solutions for this task are as follows.